Okay, I think everybody's running on low battery right now, including myself. So, and Bert set the bar very high. So I'll be trying to running faster than to finish it because probably 40 minutes will be too much. Okay, if I did it in the morning, probably you can take 1.5 hours. Okay, but anyway, the good news is that yes, I'll be speaking on something called fitness system. If you haven't heard of it before, that's very nice because I spoke on this topic probably 50 times already, over the past few years. So if you're one of those persons, you've already attended a couple of them already, you may be feel bored. So if this is new faces, this is lovely. And don't worry about, whether you understand, I'm pretty sure the main idea, you will get it eventually, okay, because it's very, very simple. So what is real system? I put it FAS, the abbreviation FAS, okay, FAS. I think one thing you can imagine, okay, how these presentations go would be just trying to get what happened, from the background cover page. That's an image, right there. That's actually like a form, right? So we have a lot of these textile things. So this is the easiest way to imagine what I probably will be referring to, okay, in the future. So in the future, I will be imagining that maybe on your phone, it doesn't have to be a phone, by the way. It could be some other mobile devices, space station, whatever. But it would be like, okay, maybe the antenna would be like having a very dynamic structures where we can activate different region if we want to, and then it will do some kind of interesting thing. So, okay, how this interesting would be really interesting for safety or maybe beyond. That will be the purpose of my talk today. Okay, so this is the outline. Okay, so I'm going to explain briefly a little bit later on. Okay, so everybody working probably is driven, the research is driven by 6G because we are in the middle of a 6G development cycle. So I'm not claiming that whatever I'm speaking about today would be in 6G. I don't think so, actually. The honest answer would be, but that would be pushing me or researchers like you to try to aim at higher targets and to see how it goes and then what we can contribute. And in my case in particular, I'll be speaking on FAS, and then the purpose of today's talk will be what is it and what are the applications. And in the end, depending how much time I have, I'll be sharing some experimental results to you as well. Okay, 6G. Okay, so I'm probably the last or second last of the speakers today, so there's no point for me to talk about what 6G will be. You guys know better, I believe, but what I like to point out is that a lot of people talk about 6G. We have a lot of these pictures from many different magazine articles, or white papers, articles, and things like that. But particularly like these particular magazine articles, okay, by Professor Yao from China. Okay, they were trying to interpret what 6G target would look like. And then I love it because it's so simple. So what they were talking about is, okay, 6G is TV new extreme connectivity. I find it very, very compact and simple to understand. So just these a couple of things would be like 30 per second data rate. Data rate is something that we keep on pushing from generation to another. But the second one, I find it very fascinating by this because it's talking about traffic efficiency input into like kilobit per second. Okay, so we're talking about every single hertz you need to achieve 1,000 or over 1,000 bit per second. That's really crazy. But at the same time, the microsecond latency is also kind of like a terrible thing. So sometimes you may probably like to mix and match to achieve something like this, but so definitely we need to reevaluate what 5G is and then where 5G actually takes us to, what directions. So I think it's useful to remind everybody of actually safe to say that, okay, so existing technology in the physical layer is really built upon multi-domain technology. Okay, yes, okay, some people call it a master model, but rather, call it because they're actually using the portfolio that actually try to maximize rather than different future. This is what my detail. So multi-domain, obviously, I like to bring up these two giants because without them, we don't have micro and multi-domain. But master MIMO or multi-MIMO have a lot of problems. The main problem is actually is being expensive. Okay, so 5G base station now, 64 antennas, 64 RF chains, but actually to go further, maybe they can justify to have larger arrays. Okay, in the future, I believe that this still will be the future. Okay, that will be part of the future for sure. But we cannot rely on this solution entirely. Okay, because it doesn't scale well. Because The reason why the base station in 5G needs to have so many antennas because they would like to do spatial multiplexing, right, to serve a large number of users. But in 5G, what happens is that they stop at 12 users. Even though they have 6 antenna, 6 power outlets, they have enough equipment to support more than 12 users, but they actually couldn't do it. They actually stop at 12. I believe, okay, this is just my guess. I believe the reason for that is because of the difficulty of getting reliable translation information so that they then can deliver the full capability of decoding to actually do that. So they have to start at 12 users because small users will be harder to get the CSI reliable because we're talking about estimating and then feedback and all these things happen. So, and obviously we have 65 talk about risk. I love risk as well. So this, whatever that is, so there are a lot of technology out there. Yeah, I wouldn't like to go to all of them. But I think to me, as a summary, like, to my own research direction, like, okay, how do we go? I think one thing for sure is that we definitely always want to have more degree freedom. That's for sure, no matter what it is, okay? Maybe just like Marco this morning talking about the stack intelligent services, you have freedom, or maybe even the beyond diagonal range, spoken by Bruno. We have this basic multi-port network. Also, the whole idea is, okay, can we make it probably less complex? Sometimes it actually goes in the opposite direction, make it even more complex rather than less complex. But more freedom is what we're looking for sure. So therefore, I try to look for what else that we can do in the physical layer, because I have to stay in physical layer because this is my expertise. This is the layer that I speak most comfortably. I try not to jump to other layers which I actually have no expertise on. So physical layer is what I try to improve, and I need increased freedom. So having worked on this field for more than 20 years, maybe more than 25 years, so it's very difficult to learn at the same time, try not to copy what other people already came up with the ideas. So therefore, I try to stay away from reading books and papers and then try to, get completely off chart, different ideas. And it turns out that, I took inspiration from Bruce Lee. So that's why Bruce Lee is kind of relevant to this presentation. So you should know who Bruce Lee is. If not, that means that you're too young. Okay. Understood. Okay, this is happen, right? But Bruce Lee actually is a movie star and martial artist. Okay, he has actually have two identities. He made a lot of movies in Hollywood in the late 60s, early 70s. But he's also like have obsessions in martial arts. So therefore, he knows Wing Chun, Taekwondo, karate, judo, whatever. Okay, you name it. Okay, almost everything he knows it. Why? Because he's crazy about martial arts, he's crazy about combat. He want to know the pros and cons of different styles, okay? So I'm not here today to tell you martial arts because I'm not expert either. But what I'm saying is that, okay, so in the end, he actually created his own martial art system called Chicken, okay? That's what he created. So it's about, okay, taking advantage of different limitations, constraints, pros and cons, different styles. Eventually, that was his idea. And he used one of the TV shows that he participated. The show is called Long Street, which was aired in September 1971 in the United States. Okay, if you're interested, you can try to find this video and to watch it. So I think in episode 6 or 7, he actually used that opportunity to share that idea. What is Chicken? Let me tell you about this. Okay, so he actually spoke about that. So this is what he had to say. So now let me try to say it. Okay, he said, "Empty your mind, be formless, shapeless, like water. If you put water into a cup, it becomes a cup. You put water into a bottle, it becomes a bottle. If you put it in a teapot, it becomes a teapot. That water can flow or it can crash. Be water, my friend." That was his idea. So it's kind of repetitive, but I think the essence is simple. Just basically the last sentence. Be water, my friend. Okay. So then how does that help us? Okay. So remember, let's try to understand it, the mind of physical layer. Okay. So Bruce Lee say, "Be water, my friend." How do I say, "Be water, my antenna"? That's very simple. Okay? That's how I try to relate his idea is about how being very flexible in combat, try not to limit his own style, everything, okay? So, and when I try to relate it, I relate it in two ways. One is actually, what is the physical meaning, even so I say you water my friend. But on the other hand, is it really sensible, or is it just like some hype that I'm trying to, share with you, like, or if you water my friend? So what happened in the physical layer over the past few decades? Well, I believe that we see a lot of "be water my friend" ideas over the past decade, even though they don't say like this. Because why is communication so terrible? It's very hostile. We have sharing, have laws, short-term fading, we have interference, we have limited resources, we have all sorts of things. So what happened? Then we have scientists, engineers, professors, research students, everybody working on this area. And then what we create is channel coding, let's say, break down the noise. Okay, we have power control. Maybe we try to compensate that loss. We also have resource allocation, because maybe this previous channel is not too good, we jump on to the other one, right? We also have MIMO now these days, right? So we try to mix and match of terrible wide signals so that we separate in the end. Okay, maybe we operate on the principal eigenvalue of the channel. Now the channel is good and stable, right? So this is what happened. Okay, so we're doing a lot of adaptation. Adaptation is the one-time antenna kind of idea. So be flexible, our network. So that's why we have constant software-defined radio idea. Everything. Try to go in the direction where, okay, we cannot be rigid. We have to be flexible, kind of like this. But of course, I took it more literally and say, well, antenna is something that is fixed right now. And MIMO is trying to do something like, yes, antenna is fixed, but so what? Let's try to invest in the space so that we put more, right? So in this position, no good, maybe the other position would be good, or maybe even, everywhere is not so good, but we can make the signal good and have the signal cross, maybe good again. So that was the idea. So then I take it to probably a little more extreme, saying, okay, if we try to invest in the area or space that we are allowed to have and put multiple antenna, why don't we put an antenna which is like a ghost antenna? Like, it could just switch everywhere we want, okay? Maybe it doesn't make sense at the beginning, but that's the starting point I have, okay? So now because of that, I kind of came up with this idea. I put current antenna system. And now, of course, if you have a little background antenna, you say, this is a reconfigure antenna. Why are you changing the name, right? So therefore, okay, probably I need to explain a little why, okay? Because when I had this idea, probably okay. So 10 years ago, I had this idea. Then the reason why we didn't say just okay, just use the name reconfigure antenna. It has been out there for decades, okay? But if we then look at reconfigure antenna literature from the antenna community, you realize that the antenna people look at reconfigure antenna is not how we look at reconfigure antenna in the communication community. Why? If you try to convince, okay, maybe now it's easier to convince the antenna expert, say, okay, try to build an antenna that to change the position of the antenna. You do the why? Why do we need to do that, right? So I give you the best antenna possible. You put it anywhere, it performs best. That's the mentality. They don't understand that there is something called, when we talk about point-to-point communication, it's not just about how well the antenna performs in terms of radiation characteristics, like radiation pattern, gain, etc., etc., but also what's happening in the wireless communication channel, which is changing over time. So therefore, they feel like, okay, I give you the best antenna. You can put it anywhere, it will perform identically the same, which is not true, right? So therefore, it would need people like us, working on the physical layer for so long, and to realize, no. And actually, if the antenna right here, right now is good, maybe later is not so good. Put there, maybe right now is bad, but later will be good. They don't understand that, so that they don't see the need of having an antenna which is reconfigured in terms of position, for example. So therefore, if you look at the literature of reconfigured antenna, you have a lot of reconfigurability like bandwidth, right? Radiation pattern, okay, operating frequency, the list go on and on. There's nothing you can find a position. That's it, okay? So that's why I feel like, okay, then it deserves a name, okay? So then I came up with a antenna system. I don't try, and I also don't want to use it like water antenna system because like the water antenna, people will be like, yeah, actually it's water. So put it kind of like a more abstract and not specific. So that I can't use this. But of course, some people later on, criticize it, say, well, this is confusing. You actually want to put it right. In fact, when I create this concept, now this concept actually represents shape flexible, position flexible intelligent system, right? So I actually have no idea how this is going to be implemented. It was after I tried to push the idea for the first couple of years, a few years back, I was suffering so much, people just don't like it, hate it, and criticize, and like, oh, that's rubbish, you have to be happy, then no, then shut up. Then eventually I feel like, okay, we have to leave, even though I'm actually not an antenna, it's just mid antenna. I need to like back people, okay, let's work together and make it, right? Otherwise, people don't believe us and people will just think that we're being stupid. So that's why I think I will try to share some experiment that we try to be antenna. So if you're tired right now, okay, at least you know what is fully antenna system. And the easiest way to understand the value of this antenna is if it's a new group. Okay, the new reason is being introduced by having the shape or the precision being completely flexible. Okay, so of course now I try to put aside how are we going to implement it. Let's forget how do we implement it. Just anything the idea for a second where we can actually have an antenna which can change the precision, change the shape, however you want it. Okay, if you have this possibility that this is a new degree freedom that you can break into the physical layer and you can do so much. So what we can do about this, but there's so much I'd like to share, but I couldn't because time is not allowing me to do that. So I will probably point you to this tutorial that we wrote. We spent 1 year to write it, and then initially people asked, okay, you will need to write something like this, and then we planned to spend 3 months, eventually 1 year to write it. And the good news is that it was accepted. I actually completed so many tutorials. It has like I think 300 references, whatever, something like that. So therefore, do take this paper up and try to read more. Okay, very quickly, potential application. I'm not going to go into details of every single application, but I think the message I want to send to you is that it's going to be very powerful, that you can easily incorporate into your existing research problem you may be working on. You may be working with UAV, you may be working on physical security, you may be working on bridge, you know other things, okay, no problem. You can easily introduce that into your own research. For example, one problem that we work on is, okay, let's say just consider the data mining. But instead of having the fixed precision antenna on both sides of how about now we have to get in space and allow the antenna position to change at the same time while you're doing this, and then we try to investigate the diversity of the trade-off. So we have this paper published in Whiteland this year, earlier in June, but I think one very quick summary is you can see the diversity shines so much simply by allowing the position to change, okay, in addition to do what normal MIMO would do. So for example, a standard MIMO, okay, given half lambda kind of place, you may be expecting 16 of the diversity order. But then if you then let the antenna go loose and then do crazy stuff, then the diversity jump to 169. Okay, so this table actually shows, depending on the allowable space at the terminal, then this changing position, how much diversity going to bring you to the system more. Okay, so this is very good to note because then, because of these advantages, well, in fact, when we do this, a huge advantage will be in terms of diversity. Then we take a look on that and then actually utilize it on other things like how about we utilize the intelligence system idea onto RSMA, no one system. Why? Because they need to do independent translation, right? So you want it to be reliable. If it's not reliable, everything go away. All this nice stuff. So, but then if you have this, actually you improve the error correction capability of normal RSMA a lot. That make it a lot more effective. So another thing that I actually, well, let's say this is a new area. My student or my postdoc and other collaborators work on across many different areas relating to or using the idea of grid antenna system. But to me, my own research as a researcher myself, I think like this idea, grid antenna multiple axis. Because I always feel that, okay, well, by the way, okay, my PhD thesis was on MIMO. That was probably in 2001. So that means I should be the first lover, okay, for multiple MIMO. So I love it so much, still today, okay. But then love is one thing, but at the same time, I also realize that the multiple MIMO probably is hitting a ceiling right now because of the scalability. we can on paper theoretically assume that everything is going to be great. And this would be because under the assumption of our consumption, CSI is going to be reliable. You know, this is so easy, right? You can do super high resolution beamforming, 1,000, 2,000, 5,000 users, so what? It doesn't really cause you any issue, right? If the conditions is right, this is easy to be to solve. But I don't believe that because I don't think we actually have that scalability for multi-survivor or mastermind. Okay, so but it doesn't mean that I disagree with moving on with extra large micro ultra mastermind. I still think that this will be the case. But I just think that okay, you do it for certain benefit, but but expecting that this will solve extreme market connectivity issue is not okay. This is not true. So therefore, I start working on the idea of free antenna multiple access system and making a very strange assumption. Okay, I'm not saying that this assumption will be a good assumption, but it's good for me. Good for me in the sense that I want to start off with a completely different problem. So what was the assumption? The assumption is that how about I don't actually have any CSI in charge? Then no pre-coding, sorry, right? So then therefore I can't start with a very strange problem and say, okay, let's assume that yeah, I have multi antenna at the base station, but I don't have pre-coding. I don't have CSI. So but I still want to do master model access. So what are people doing? Maybe no more with RSMA, but actually they still need CSI in computer because they need to do this grouping, power control, etc. But I'm not doing that. I'm not doing any of this, okay? But then I still want to do multiple access to the receiver. So, but then it turns out that I feel like the position flexibility becomes a very unique thing I can exploit for multiple access. For example, giving these two users to transmit to receiver, the only difference here is that the user side, I'm assuming that I have this position flexible antenna, so I can actually switch. So then the good news is that okay, two signals come in at the same time in frequency, but right there, because I have this new crazy boosted antenna, so that I can access the signal in space, in this entire space, rather than a single signal point in space, because I don't have a fixed location to receive it, but I actually have like a range. So what we can see is that the signal actually kind of smooth because the signal is correlated, spatial correlated. Right, another observation we may see is that there is some peak of the signal. Why? Because it's what we call channel fading, right? When there's a rich scattering, multipath, and also sometimes some space. So this is the opportunity that I can actually get the receiving of the true signal which I want, but I don't need to do anything except to switch that location where the interference will be gone naturally. Okay. So interference is appeared because of natural propagation due to the environmental impact. Okay, so therefore I realized, okay, this is actually good because it's still rely multiple access a lot. I don't need CSI base station, no pre-coding, and the receiver also do not need interference cancellation. That's nothing we need to cancel. It just cancels itself due to multiple gating. Okay, so therefore I from some papers on that. This is like the first version, but in fact there are other versions I can do, but it turns out that I can generalize this idea into dealing with more than one user, maybe 2, 3, 4, 5 users. I have different versions of the method. Some are not very realistic. I still try to figure out how we can deal with it. But hopefully, okay, maybe I can update it again. But this is one area that I feel very interested in. This is another idea, also doing lots of access, but instead of choosing one lucky position when the computer is gone, but I kind of activate a large number of position and then try to mix the signal in the analog domain and do something, and it turns out that I can actually deal with like 30 users, okay, without recording, no interference cancellation, and of course with 2-hour change, okay. So that's all the details I try to omit today because that's not the point to go down to too much detail. And also, one thing that we try as well is, once we have put in the system as a user, and then we're doing these sort of, new signal processing, okay, and the receiver side, we can actually, in this world, we reduce the requirement of the base station to do recording. Do we still do recording for this one? Yes, but we're doing recording simply based on statistical data. But then the receiver is doing some crazy simple combining integrated system. Then we can actually scale up the class with even 1,000 users. It took me like 3-4 months to get this simulation. So therefore, you take a look at that. Creative system can be utilized in the low system. It doesn't have much advantage in terms of the rates, okay? But is the diversity that we're looking for that we can exploit to improve normal system. For example, you can see these horizontal lines indicating the power consumption reduction that we may be able to achieve if we use a printer system compared to the traditional printer system or normal system. So I actually thought that Bruno would be here, so I particularly created this library. Come on, RSMA, okay, we can use printer system on that as well. And then you can see, okay, so what we can see here is, okay, all this line, okay, is about the quality for the RSMA system with conventional printer system. But then the slope is so much steeper, okay, for ultimately when we replace the transition antenna system to printer system. So then, it actually helped RSMA a lot, okay. So there's collaborator Wong from China. He was using printer system and also some IO base station and to do ISAT. Okay. So what we see is that the performance actually jump. Okay. You see the horizontal line is the one that we don't use printer system, but the one after the jumping will be when we replace the fixed position antenna system to the printer system. So that was the degree of freedom. What is being increased actually shows up, okay, in terms of performance. So that would be other things that we can try, okay, for the system, open risk, okay, and all that. There are many, plenty more examples that I try not to go through. So mobile edge computing, physical layer, security, over the air computation, I think we speak on that, right? So and swipe, food interest communication, OFDM system. There are a lot of these different applications that you can bring printer system in. Okay, some of these we discussed in this paper. Some we actually published separately in conference or journal, so that do try to take a look and to see how that it would help your own research to improve performance. Now, okay, so let me try to use the last 2 minutes. Okay, trying to overrun too much. Is that okay? Yeah, theoretically it sounds nice, sounds sexy, sounds fashionable, whatever that is. But is it real? Okay, that is the question that I'm being asked probably 2 years ago a lot. Sounds nice, good idea, but it's not real. Okay, nobody will care, right? Maybe we come back to it 10 years later, whatever. So I was so discouraged, but I realized the need, the strong need of making these real, okay, so that people would then pay more attention to say, oh, well, maybe this is really what is going to happen. Well, I'm not talking about 6G because we never have any say about what 6G is anyway, right? So therefore, I'm happy to say that at least we have 3 prototypes, and then we're making a full prototype and trying to improve the results using different technologies. For example, today I list these three based on 3 completely different technologies. Okay, so what does that tell you? This tells you that I don't mind what technology we're going to use. Okay, I just want to explore any possible technology that may be able to realize this concept. So the first version that we made is for liquid-based surface weight enabled printer system. So basically, this work is done by my colleague Kenneth Wong, the professor of antennas and propagation, and also collaborating with Dr. Wong over there. This is actually the prototype that we made inside this container. There's a little tube where we actually have a little actual inside that we use air pumps to shift the antenna material inside that tube. So we actually change the position like that. They, would be able to pay just quite recently, early this year. But actually, they made it like at least 1.5 or 2 years ago. Okay, but when they showed me this, I was very happy. But then the next minute, I was complaining. Already, I was like, oh. It's so nice to actually see it because I envisioned this idea. I never realized, when I could actually see it in front of me. That's the good news. But the bad news is that when I realized that, when we change the position of the antenna, we take a second or two, I'll be like, oh, we're there, okay? So, well, in fact, it turns out that it's not there, okay? Because it really depends on what you want, okay? If you actually want to change the antenna position in a matter of seconds. Maybe it's still valid in terms of steering the angle right, whatever. Okay, all this statistical channel knowledge, this is probably good enough. Okay, but I'm a physical layer person. I always play with these design. Okay, somehow for so many years that I forget about how to use it for statistical design. So therefore, I feel like, come on, you guys, this is so nice. This is not good enough. We need to work again. Okay. So therefore, of course, we continue. So that's why it leads to the other two design. The second one is pixel reconfigure antenna, for antenna system. Okay, we got it just recently published in the Journal of Antenna Propagation. And it was made by a team of professors Wong from Hong Kong University of Science and Technology, and he was actually my former PhD supervisor. Okay, back then when I was doing PhD with him. Okay, he is an antenna expert, physical layer expert. I think I was the first student who did physical layer with him. But then he separately already exploring using what they call pixel reconfigure antenna to do whatever crazy antenna. But I realized there's an opportunity to use that to realize the concept that I have in mind. So this is the prototype, let's say. So you may look at it and say, wow, this is the risk, right? I say no. Okay, why? Because all these little things with one pixel, it is not an antenna. Right? If it's risk, each of these little elements, okay, come on, it's an antenna, right? So refraction or maybe active with transmission. No, this is not. Each pixel is a Lego. Right? So you have a Lego, I'm giving you a Lego, okay, to start with. And then you try to make the connection of optical connection to the Lego to realize whatever that you want. Okay. So these pixels, kind of like a planar surface with a lot of pixels, in fact, optimization is done through the connection between the pixels. Okay. Right? So after that, it could create, let's say, a number of reconfigurable states. I'm trying to use a more abstract name, reconfigurable state. So each reconfigurable state would represent or can be interpreted as some antenna being created on the surface with certain shape, certain size, and radiating with certain frequency, and then radiating at certain location. So this is what it is, okay? So therefore, this is a frequency system actually using these pixel reconfigure antenna. So now you may then wonder, okay, if I do this, well, that's so many connections. So the real-time optimization will be crazy. So how? Okay, the good news is that all these connections is pre-optimized before you use it, okay? Let's say they decided this, and eventually, let's say this one. Okay, we can produce 12 reconfigurable states. That means maybe 12, radiation, characteristics that happening in some position with certain polarization, certain whatever. Okay, so this is pre-optimized offline. So when somebody gives you that, then you try to do signal processing. It's the same thing. There's only 12 states that you can choose, and mixed with your normal signal processing. Okay. So the more I work with it, the more I understand this, the more I realize, iron and the Marco, they are really, how do I say? So they have really good vision. Like they already have an ETI, the console, right? Electromagnetic information, signal, something like that, right? So when I try to understand how that works in the end, I really have a strong feeling, okay, we are actually doing exactly the same thing. We are mixing the EM responses optimization with the signal processing together. So when this is being optimized with radiation, there is actually something going on in the NR domain, right? So we try to, what pattern is going through here and there. And then, of course, when we operate this, we do, for example, we can do encoding, maybe we do beamforming, whatever. So there's a signal process that's going into it. So therefore, these design actually screen for a joint optimization in the EM domain and a signal processing. That's how it is. Okay, of course, it doesn't look like stack, okay, or this is the stack services. So, well, another good news for this one is that if I switch from one state to another state, there's no delay. It's the electronic, it's DSP. So that for microsecond, no problem. Less than microsecond, no problem. Okay. So the first design that we try is this one. These guys, okay, Dr. Liu from Shenzhen Technology University, and also collaborating with my colleague Kenneth and Steve. Okay, they make something like this using a completely different technology. Actually, this one is using metal material. Okay, technology. Okay,
So this is a single antenna, okay? One low, one feed, whatever, but
Over there, there's some sort of like legislative structure where you can turn on and turn off. So what happens then in the end, okay, the back is the MPA, so they can actually relocate the aperture, the antenna aperture. I can make it right here, I can make it right there. So effectively, it's changing the position of the antenna without actually moving anything. Okay, so therefore I like that as well. So this is the prototype. So Ross also tried to use these that pixel reconfigurable antenna or antenna system in the lab, okay, and try to observe what's going to happen. Okay, what if I have two transmitter using his manual testback, and then I have one standard receiver, the other one is using the antenna system. What does it look like? So over there, this is the measurement result. Okay, so the measurement results where, okay, like I said, these one they produce it at I think 2.4 gigahertz, and it has so far started with different states. Then you can see two users coming in at different states. So user one looks something like that. User two looks a bit different. So those results is good in the sense that it validates the our understanding or our assumption that okay, user one, user two is going to look different, so therefore maybe we can activate if let's say if we want a red signal, maybe we activate on the first state, then the blue signal is gone, right, very small. Or if we want to have the blue signal, we activate somewhere right here, so therefore the red signal is smaller and the blue signal is going up. Something like that. That would be, achieving the concept of real access that I earlier mentioned. So, we're going to try to do more right now. There's a discussion that I try to ask them to produce more prototypes and share in the community so that other people can take up this idea and demonstrate that also the processing techniques. This is going on. So the last term I'm going to share today is, let's say these, okay, method service kind of using metal material for that antenna. This is a simulation, but of course we made it. This is the actual prototype. This is actually the results. In here, we have to try 3 users. Okay, we're sending 3 signal and looking at the different antenna system, as a receiver, and see if I change the so-called the position of the aperture, are we able to get good SNR, right? If we can get good SNR, that is okay, no problem. We can deal with the injuries. If not, that's bad, right? So let's just look at this. Let's say I'm trying to see a system signal at this one. So we repeat the experiment for like 10 times. We want to do more, okay, it takes time and money. So these antenna, and actually we have 120 positions that we can change the antenna pocket, okay, we change it. So therefore I can expand, let's say in this instance, so I have 120 locations. If I actually expand the location, what would be the SIR, which we can measure. So then we can see that over these, then maybe I turn to this position, I get 13.41 SIR, right? This is how we understand these data over there. So, well, that's good enough, okay? If we talk about we have free user, but doing nothing about the coding, require no CSI, right? And then we're not even doing inference calculation. We didn't have free user, and then we get quite decent SIR, right? 40 dB, right? So if we have this, there's no coding. With coding, probably that would be good enough, okay, for our communication. So, even I started this work and I didn't expect to try to contribute to the low latency, ultra reliable, whatever communication. I think the latency of maybe 5G or if we take it forward to 6G, most about the latency is contributed by the protocol. By the protocol stack, which is getting more and more complicated, right? And because we need multi-survival to work well, that also means that we need to do a lot of preparation in terms of CSI estimation, feedback, getting everything right, doing a huge amount of optimization. Otherwise, we cannot make the signal to be right in order to be able to be received reliably. But this is like we are cutting a lot of these sort of overhead, right? And then we just deal with that, okay? If we can do this, I believe even though we didn't plan to do it, then the latency will be shorter. If we, right, you don't have to do this, then the protocol is going to be lighter, and then you will have a lot of fun from that. So there are a lot of things that I would like to talk about. This is actually still a very open area. So there will be, well, it's like that if you ask me a question, there are a lot of questions I actually do not know the answers. Okay, I have been like that. Okay, since the beginning, a lot of people ask me, okay, what's going on? How do you do channel estimation? Now I know, but before I didn't. Just okay, please, okay, be more open-minded and let me deal with it later. But that doesn't work. So eventually, we try to solve everything by ourselves. Hopefully, this is not the case going forward. So if you want to find out more information, there's a web page that we created, and then over there will be like list of publications, not our publication only. There are other people working in this area, so therefore we like to have a space that is easy for people to take up the idea. And also there are tons like recorded video. If we did some presentation online, recorded this over there as well. There's also the recheck group. For that, we actually create two because the first group already oversubscribed with 500 people. So the second one now have 260 people, something like that. So the QR code doesn't work anymore because we have 200 people. But if you're interested in this area, you want to find out more, and you also happen to be a WeChat user, add me. Okay, I'm going to send you an invite and then bring you to one of the WeChat groups so that you can have some updates from that, and you can also take advantage of the community over there that benefit your learning, taking up of these ideas. Really, last slide. Finally, we have the JSAT, a special issue, printer system and other next generation reconfigured antenna system, provides conditions. Submission deadline is February next year. So if you work on this area or actually utilize this in your research, please do try to consider submitting your work to our special issue. Hopefully, you're still up there. Okay, thank you very much. That's all for me.